Let's move on to a bit of variable acceleration now. So we can't necessarily just use suvat because the acceleration is varying. We're going to have to use differentiation, integration, that sort of thing. So I'm going to start with an exam question. I hope you can see this. It's one of the sort of smaller resolution images of a question I've used, partly because there's a graph that needs to be shown as well. So do try and zoom in on it if you feel that you need to. So this is more about just interpreting, what you can see in a graph. It's what kind of graph is it? Displacement time, and you've effectively just got a few questions getting you to read off the graph. Do be careful because this graph itself is in some sense split into two parts. So you'll see that they'll refer to a time of between 0 and 3. You've got this expression. So that is between 0 and 3 here, so just until it crosses the x-axis, or in this case the t-axis. That is described by this. But then after t equals 3, so this region, it's potentially a different equation. Okay, but that's for you to find out. I'm just going to point out here in question in A and B here, part of I, the wording of this initially confused me. It's not a very complicated question, but I just want to clarify the wording here. For A, it says, what is the greatest displacement of P above its position when t equals 0? Perhaps I feel like a comma should go, so how should I put it? The greatest displacement of P above, or if you could do such a thing, if I can apply a bit of maths to English, I would say if we bracket sort of around this bit, its position when t equals 0. Okay, so its position when t equals 0 is simply saying a specific position. Okay, so I'm just going to tell you this one because it's obvious from the graph. What is its position when t equals 0? It's here, right? It's at 12. Okay, so really when it says the greatest displacement above P, the greatest displacement of P above its position when t equals 0, it just means the greatest displacement of P above 12, right? And the greatest distance of P from 12, or specifically, y equals 12. Okay, so you can replace those last few words with simply the idea that you're talking about the initial displacement, the initial distance, which is 12 in both cases. Okay, so have a go at this question. Hopefully not too difficult. And I think I've just cut off a little bit here slightly on the right hand side. This wording here, it says there is no sudden change of velocity. So let me just write that on actually. Okay, you're missing the word of there, slightly cut off. And this part here says use calculus to find expressions in terms of t for the velocity and for the acceleration of p in the interval. It should be fairly obvious really. In the interval 0 to 3. Okay, give this question a go. Pause the video now. Okay, so part A, the greatest displacement of P above its position when t equals 0. So remember, displacement and distance, they're different. Displacement has direction, it can be positive, negative. Distance is always positive. So the greatest displacement of P is going to be what? So let's just think about what the displacement is as I move along here. From the initial position, displacement is 0. Okay. Then over here, we're at 16, so I've got displacement plus 4. Over here, I'm back to displacement 0. And then for everything below, there's some negative displacement. Okay, because we're talking about relative to this initial point. So it went up to a max of 4, back to 0, and then it went negative. Negative displacement down here. So the answer for A is just going to be 4 in this case. Then for B, slightly different. What about the distance? So here the distance is 0, here it's 4, here it's 0. Then as we go down, because distance can only be positive, we're getting positive distance. So down here is the difference between 12 and 8. So distance 4, distance 8, distance 16, 12, distance 12 here. And then over here, at the lowest point, we've got distance 16. So in that case, the maximum displacement is just that. It's 16. Maximum distance, I should say. Maximum distance is 16. Okay, what is the time interval in which P is moving downwards? Well, seeing as this is displacement time, moving downwards simply corresponds to the displacement, the displacement decreasing. So here it's going up, and it's just how it looks. It's going down here, it's going down, and then here it starts going up again. So it's effectively the time between these 2 points, correspondingly between 1 and 3.5. So the way I would express that is to say t greater than 1, less than 3.5. Okay, and no equals sign under the inequalities, because when it's equal to 1, it's not moving downwards. In fact, it's instantaneously motionless or unchanging displacement, and likewise for 3.5. So don't do less than or equal to, it's just less than. Then for D, the times when P is instantaneously at rest. Well, we've basically just got that from C. It's t equals 1 and t equals 3.5. Okay, done. So then double I, we're going to use calculus to find expressions in terms of t for the velocity and for the acceleration. Okay, in that range 0 to 3. So you can't see it on the screen now, but we were given it in the question. S was equal to minus 4t squared plus 8t plus 12. Okay, quite a nice simple question. We're just going to be differentiating. So to get from displacement to velocity, I differentiate. So I get minus 8t plus 8. Velocity to acceleration, I differentiate. I just get minus 8. And there we go. Those are the expressions. So double I done. Triple I. At what time does P have a speed of 4 meters per second in that interval 0 to 3? At what time? So here's 4. Read it off the graph. Go down. And therefore, hang on. No, completely wrong. What am I talking about? What have I just done here? Ask yourself, what on earth am I doing? Here, I'm reading off a displacement of 4. So the displacement of 4, at least relative to 0, is about 2.75, but that's not what it's asking for. It's asking for speed. Okay, so for that we're going to have to go back to our calculus. What did we just calculate here? We got v equals minus 8t plus 8. Let's put that here. So speed 4. Speed 4, interesting. Can we just put in 4 instead of minus 4? Well, let's see what happens. Because I mean, speed of 4, that technically means, you know, when v equals 4 and v equals minus 4, it could be either one, right? Because speed is the absolute value of velocity. So the velocity could be 4 or minus 4. Let's try the first one. When v is 4, we get minus 8t plus 8. That implies 8t equals 4. Implies t equals a half. Now, just out of interest, if I did minus 4 equals minus 8t plus 8, what would happen then? I'd get 8t equals 12. T equals 12 over 8. Equals 3 over 2. Equals 1.5. So here I've got 0.5 and 1.5. Okay, so there's two possible times, right? So let's look at it on the graph. At 0.5, that's about here. Okay, so here it's got a velocity of 4. Okay, and you can't tell that from the graph, right? You can't read off 4 anywhere on the graph because this is a displacement time graph, not a velocity time graph. We got this v equals 4 from using calculus and knowing the equation of the graph. 0.5 has velocity 4, and apparently from calculus 1.5, that's here, isn't it, also has velocity 4. Looks about right, doesn't it? Minus 4 in this case, so speed of 4. That looks about right because it's effectively saying the gradient here is 4 and the gradient here is minus 4. Both of those correspond to a speed of 4. Okay, so those are your 2 times there. In fact, that was the hint, wasn't it? It says times, not time. Okay, and then the last one, in the time interval from 3 to 4, so we're looking in this time interval, it has a constant acceleration of 32. Let me write that down. And there is no sudden change in velocity when t equals 3. Okay, so this part here, there is no sudden change in velocity when t equals 3. All that's saying is you can find what the velocity for t equals 3 is by looking at the equation we previously had. Even though that equation does not govern this period of time, it governs this period of time. So what was that equation? It was v equals minus 8t plus 8. So to just make it clear here, I'm saying this, can I highlight that actually? This this sort of highlighted bit, okay, that is described by, for this region, we've got v equals, what was it, minus 8t plus 8, okay, but for this second region, I mean, it's something else, we don't really know. Okay, v equals, don't know, because we haven't been told. Okay, so it's undergoing some other kind of motion apparently. But the key thing is that at this point t equals 3, they are the same. The velocities are the same. That's what this is saying here. There's no sudden change. So that means we can use v equals minus 8t plus 8 to get this point at time equals 3. So let's try it. Minus 8 times 3 plus 8 equals minus 12. So therefore, here we've got a v of minus 12. At that specific point there, v equals minus 12. Okay. Let me now read the question actually. Find an expression in terms of t for the displacement of p in that interval between 3 and 4. Okay, so basically we're trying to find the equation of this curve. Okay, now we can use a bit of suvat because in this specific instant we're told acceleration is constant. So if acceleration is constant, what's the initial speed? It's just minus 12, isn't it? The initial velocity, I should say, minus 12. Okay, because the initial velocity of the green section is the same as the final velocity of this brown highlighted section. T is the independent variable and s is the dependent variable. Let's find the equation then. So it's s equals ut plus a half at squared, and in this case it's s equals minus 12t plus 16t squared. Okay, now here is where we have to be very careful because this is not quite the final answer. And even I, when I first did this, I thought, it seems, quite simple enough. Also, I've made a mistake here. I'm not going to go back and edit this. So if you do bring it up, keep in mind that I've spotted it myself. What on earth was I thinking here? When t is 3, minus 8 times 3 is minus 24, plus 8, that's minus 16. Okay, so minus 16. Sorry, let's change that there. Okay, so we've got this. Right, so going back to my previous thought, this is still not the final answer because this t is the time as measured from this point here. So it's like saying this point here is 0 and then time continues onwards and we get this curve. Okay, so it'd be a bit like if you imagine, let me just highlight this in green. So this equation here, right, what this is really describing at the moment is something like this. Okay, that highlighted green bit, it's doing that right now, isn't it? Because when t is 0, we get 0, and you know, when t is 1, you can see it's going to end up crossing back over. It's effectively a shifting of this one. Okay, and the reason for that is because it's taking t to be 0 here. But we don't want that. We want it to be taking this as time 3. So there's a little trick we can do to correct this. Okay, and it's effectively just shift the graph over. So if I want to move it over to the right, I'm just going to take away 3 from t. So I'm going to get this. Yeah? Does that make sense? Just by taking away 3. And in fact, instead of doing it that way, let's factorize it first before we take away the 3. It makes it a little bit easier. So let's instead say this is minus 16t times, let's do this correctly, 1 minus t. Yeah? So then I've got, and let's also just change that around then, get rid of some minuses. That's the same as this. Okay, now, I shouldn't say equals. I'm gonna do a shift, t goes to t minus 3, and now we have s is equal to, and this will be our final correct one. This is, let me write it in green in fact, just to highlight the fact that this is in fact the true equation of the green section. So this is s equals 16 times t minus 3 times t minus 3, and then there's a minus 1 in there. So that's 16 times t minus 3 times t minus 4. Okay, so that's our answer there. That is the expression for the displacement in terms of t for this region here. That's the answer I get. Officially, the answer, when you multiply all that out, is to get this. And I think the reason for that is that the official answer actually uses a slightly different method. However, I'm quite a fan of this method because it's quite a good way to even get the factorized form without even having to factorize the quadratic. Just use suvat and then shift the time, and then you get this. And that's quite an advanced trick, so if you can understand it and use it now and again, it'll be quite useful. Cool. Okay, is that the last question, I think, in that section? Yes, it is. Okay, so there you go. That's the final answer for IV.